In this question, we're told the points A, B, and C have coordinates -7, 3, 2, 0, -3, 5, respectively. We're also told the line L passes through C and is perpendicular to AB. So as you can see in this question, before I even think about the questions itself, I've just left myself a space to sketch and diagram of actually what's happening here. So if I start off, let's just randomly call this point here -7, 3. I'm then going to sketch the other points in relation to that. So the point B is 2, so it's to the right of point A, and it's the y coordinate 0, so it's below point A. So I'm just going to put that somewhere over here. I'm going to call this B, which is 2, 0. Finally, C, which is a little bit trickier because I've now got to put it into perspective with two other points, is -3, 5. So it's in between A and B. It's a little bit closer to A, but it's higher than A. So I'm going to put it around about here. And we'll call this C -3, 5. Now what we're told is the line L passes through C and is perpendicular to AB. So if we imagine I've got a straight line, it's not a very good straight line, I appreciate. There's my line AB. And then I've got a line that's going to go perpendicular to AB that passes through C. So again, it is just a sketch, but this is the scenario that is explained to us in the question. So that is the line L. Okay, so let's have a look and see what questions we're actually looking to solve on this. So first of all, we're told to find the gradient of AB. So A part I, let's find the gradient of AB. So M is going to be y2 minus y1 over x2 minus x1. So M is going to be given. Let's take B as the second coordinate, as on my diagram it was the coordinate on the right hand side, and if there's a negative to be avoided I can do. So the y coordinate is 0, the x coordinate is 2. Then I'm going to subtract the A, so I get 0 minus 3 over 2 minus 7. So we get that M is -3 over +9, which simplifies to 1/3, or -1/3. Part 2 says to show the gradient, show the equation of AB is this equation x plus 3y minus 2. So using y minus y1 equals mx minus x1. I'm going to substitute in a gradient and a point. The point I'm going to choose to substitute in is the point B because it will be simpler given that y is 0. So when I do this, I get y minus 0 is equal to -1/3 x minus 2. I'm going to times everything by 3 to get rid of the fraction, so that I now have 3y on the left hand side. Then expanding by multiplying this bracket by -1, I get 2 minus x. And then all that's left to do is to add x to both sides. So let's add x to both sides and subtract 2 from both sides. And so I get left with x plus 3y minus 2 equals 0. Okay, in part 3 it wants to find the equation of L. So if we just go back to our diagram a second, remember that our equation L, we've got the equation of AB now. The equation of L, well, L is perpendicular to the line AB, so I can use the gradient of AB to find the equation of L. So in order to find the equation of L, I need to find that M1 equals -1 over M2. So I'm going to get that my new gradient M1 is equal to -1 over -1/3. So my new gradient here is 3. So substituting that in using C as my point that the line passes through, I get y minus 5 equals 3x minus 3. So I'm just going to expand and simplify that. What I'm going to do is I'm going to add 5 to both sides so that I get left with y is equal to 3 times x is 3x, 3 times plus 3 because it's a double negative is 9, and then add the 5 from the other side at 3x plus 14. Okay, so let's look at the next part of the question. Next part of the question says the line L intersects AB at the point D. Show that the coordinates of D are minus 4, 2. So we've had the equation of our line. Our first equation of a line was x plus 3y minus 2 equals 0. And the equation of my second line, so let's call that 1. Equation of my second line was y equals 3x plus 14. So what I'm going to do is I'm going to sub equation 2 into 1. Remember to communicate how you're doing simultaneous equations. It's method marks to be awarded for using correct methods, and so you need to demonstrate those techniques clearly. So substituting that in, I get x plus 3 lots of 3x plus 14. So there you go, I've substituted out the y for 3x plus 14. Minus 2 is equal to 0. Expanding and simplifying, I get x plus 9x. We then get 3 times 14 is plus 42. Minus 2 equals 0. And so when I tidy this up, I get x plus 9x is 10x. 42 minus 2 leaves me 40, so I'm just going to subtract 40 from both sides of the equation. So I get 10x is equal to minus 40. And so I'm going to divide by 10 to leave me that x is minus 4. And that is indeed part of the coordinate that I want for x. So now let's just find y, sub it into equation 2 is the simplest one. So y equals 3 lots of minus 4 plus 14. And so I get minus 12 plus 14, y equals 2 as required. And so D is in fact the point minus 4, 2. Okay, so that was part B. Part C says show that L is not the perpendicular bisector of AB. Now, in order for this to be the perpendicular bisector, it must cut it in 2, and so D must be the midpoint of AB. So if we go back a second and just look at the coordinates for A and B, so it's minus 7, 3, and 2, 0. So minus 7, 3, and so that was A, and B is 2, 0. If I just find the midpoint and show that it's not the midpoint, that will be good enough. So the midpoint is equal to minus 7 plus 2 over 2, and 3 plus 0 over 2. So the midpoint is given as minus 7 plus 2 is minus 5 over 2. I'm just going to leave it as a fraction. And 3 plus 0 over 2 is 3 over 2. So therefore D is not midpoint of AB. And so L is not perpendicular bisector of AB. Okay, so just be clear at the end, explain what you've shown. So by finding the midpoint it will get you a mark, but you need to then explain that because it's not the midpoint, that it's not the point D, so D is midpoint, that the line L isn't a perpendicular bisector. Okay, so finally it says find the value of tan ABC, giving your answer in its simplest form. This is worth 5 marks. Quite a lot of marks available for this question. So if we just go back to the beginning and my diagram, what we're looking at here, if I can now label this as D, and this is -4, 2. What I'm looking for is if I connect up badly, sorry, with a line here, the angle ABC, so angle ABC is this angle here. So this is ABC. Now when I consider ways to find this angle, what you'll notice here is that I've formed a right angled triangle. So there's a couple of ways about it. So if we just go back to the question, it says find the value of tan ABC. So trying to find that value of tan of this angle. So tan of this angle, if I was doing tan ABC is actually going to be opposite, which is CD, over adjacent, which is BD. So in order to solve this problem, I first of all need to find the length of CD. I then need to find the length of BD, and then I can find the the value of tan ABC by finding their ratio. Okay, so I need the points C, D, and B. So let's go back and just remember B is 2, 0. C is, I believe, at -3, 5. And D, we know, is -4, 2. So first of all, let's find the length of BD. It doesn't matter which one we do first of all. We're going to do this using the length of a line, so that's length of AB. Remember, AB is any side. This is given as the square root of x1 minus x2 squared plus y1 minus y2 squared. So BD, square root, let's take B as the second coordinate, so I'm going to get 2 minus -4 squared plus 0 minus 2 squared. So 2 minus -4, I get 6 squared, plus 2 squared, so I get 36 plus 4, get an answer of root 40. I can simplify this. This has a square factor of 4, so I can rewrite this as root 4 times root 10, which is 2 root 10. Let's now do the same for CD. CD, square root, I'll take C as the rightmost coordinate, so -3 minus -4 squared plus 5 minus 2 squared. So -3 minus -4 squared is going to be -3 plus 4. So I get 1 squared, which is 1, and then I get 3 squared, which is 9. So 1 squared plus 3 squared, 1 plus 9 is root 10. So root 10 doesn't simplify at any point. Now what we stated earlier was that tan of angle ABC was equal to, let's just go back and check that. So tan of ABC was opposite, which was CD, over adjacent, which is BD. So I get CD, which is root 10, over BD, which is 2 root 10. So we get an answer of 1/2. Okay, well let's look and have a look and see how the marks are awarded in this question. So going back to the very beginning, first of all, there is a method mark if you have tried to use in some way the increase in y over the increase in x. So that's your method mark. And there is an answer mark for a gradient of 1/3 or an equivalent fraction. Next, you get a method mark if you have attempted to use y minus y1 equals mx minus x1. And you get an answer mark if you if you've substituted in the values incorrectly, and then an answer mark if you have convincingly come to the result of x plus 3y minus 2 equals 0. Next, you then get a method mark for use of this property, or m1 times m2 equals -1, in order to find a gradient. And then finally, we get an answer mark if you have got the correct gradient and substituted it into y minus y1 equals mx minus x1. Okay, so let's look at part B. Part B, first of all, there is a method mark given for attempting to solve the equation simultaneously. So really the method mark is here for communicating that I've attempted to solve it simultaneously, but really it's at this stage here that I'm getting that mark. We then get, if you get to the answer, -4, 2, so down to this point here, convincingly, so that's making sure that you've shown your working and demonstrated the operations that gave you this answer, you get your answer mark. Okay, so next is part C. Part C was finding the mid, as shown it wasn't a perpendicular bisector. So you get a method mark if you've attempted to find the midpoint in some way, and then if you've actually shown that the midpoint isn't the point D, by getting the correct coordinate and stating that, you get your answer mark. Okay, so then the final part was worth lots of marks. So there's a method mark for correct method here of finding the length of either BD or CD. So if you've used the length of a line equation, there is then an answer mark for the third. I mean, root 40 is fine, but the equivalent to root 10 is more useful. There is also an answer mark for finding the length of CD. There is then an answer mark, a method mark for, I mean, it's all the way back here, really, that's where my method mark was given, for identifying tan ABC is CD over BD. And then finally, the answer mark is given for finding that tan ABC is 1/2. Okay, well I hope you was able to follow my solution and that you understood how the marks were awarded in that question.